Hello guys, welcome back to another YouTube video. Today, this marks the first episode of the series of file compression. So as you can see, for today, we're doing TXT file compression, and if you follow along with this video toward the end, you will get the files, the first file, the second file for compression, and the first file and also the second file for decompression. Okay, let's start guys. So first of all, here's text compressor 1. I personally don't want to type this out again, so I'm just going to explain how this works. So first of all, I did this incrementally. That's why there's 3 versions and not just one of each, not one compressor and one decompressor. So basically, this first version, it starts with a byte. Why a byte? Because how I want this project to work is it needs to download to the user a file with the compressed. It needs to download. Let me rephrase that. It needs to download to the user's computer a file of the compressed contents. So the original file, but the contents are compressed. And that would require manually compressing each byte. So first of all, to make it simple, I just tried to experiment with compressing bytes. So I just took an example byte 110111010, and the algorithm I'm gonna use is run length encoding, which basically means that you guys see how I have like 2 ones here in the 10. It basically means you write the number of times that number appears in a row in front of it, then the number. If you guys didn't understand that, let me show you. So if you have the number 111, it appears 4 times. So you would delete it, put 4, and then 1 to show that 1 appears. 1 appears 4 times. I do that, and that's how I compress it. But an important thing is if you have like 0 or just hold on. If you have 0 or just 1, you shouldn't write 10 or 11. You should just write the number. Yeah, so for this byte currently, can you guys guess what the compressed byte would look like? You guys probably already saw, but pause the video and try to guess. Okay, the compressed byte, as you guys already saw before I deleted it, would be T1 because there's 2 ones in front of a 0, 0 because there's a singular 1, singular 0, 2 ones again, a 0 and a 1 and a 0. That would be the compressed byte. Okay, well, let's look at this code. So basically, in a row count, for me, I put this counter to signify how much times it's in a row. Like these 2 ones, there's 2 in a row, 2 in a row here, 1 in a row here. Basically, this starts out 1 because the number exists, so it's already just by itself, so it's 1. The current bit is like the first number. I started it at 0, and now I'm gonna make a loop from 1. So the first number and the first original byte I and current bit are not the same. I made current bit always 1 index behind, but this loop goes to length of original byte, length of this, which is 8, obviously, because byte is 8 bits, and then it checks if the current if original byte at I is equal to the last index current bit, then in a row count plus equals 1. What this basically checks is if the previous number is equal to this one, the count is plus equals 1. If it doesn't equal, it checks if in a row count is less than 2. If it is, to compressed byte or the new byte, or like the resulting byte, it has its current bit by itself. Current bit by itself, the reason that's current bit by itself and not in a row count is because what we talked about, how if it's 1 or if it's appears 1 time, there's no point in adding the 1. It just makes it longer even. So we just have current bit here. And else, if it appears more than one time, we can add. We might if it appears like 2 times, the storage might be the same, but in other cases we might save some space. Yeah. So we add current bit plus in a row count. The reason for a string is because it's in here. It's defined as 1. Okay. And then in a row count is equal to 1. The reason this is in this else is we don't want to reset it if the previous if it's the same as the previous, because that would just like reset it. And if it's in a row, we need to keep the in a row count at the same value and not reset it. And basically this part is at the end. I'll explain later in a second, but basically this current bit now is original byte I. So if the current bit's like 0 and current bit and like original byte is 1, it like advances both positions. So the current bit becomes the new like the current bit becomes like the current value like 1, and in the next iteration original byte becomes 2. Okay, now for this part. You guys might be wondering, why is all this here? And it's probably confusing to read, but let me explain. This checks first if I is equal to length of original byte minus 1, which checks if we're at the last element of original byte, or if I is equal to the index of the last character at original byte. If it is, if it is, it does stuff. If it's not, it doesn't do anything. So if it is, it checks if the last character is equal to the second to last character, and in that case, it kind of like it stops appending, it stops iterating in a row count, and it to compress byte it appends in a row count as a string in original byte, and if it's not equal, it just adds the number. The reason these numbers are the reason these indices in indexes are so specific is because when I tried running it without this, for some reason it wouldn't do the last two numbers. So I had to make it work. So I just tried to a little bit to trial and error, and this worked. Okay, that covers the text compressor. Let's go on to the text decompressor. So far how this works is this looks through each number, sees if the next number is the same. If it is, it adds to the current counter in a row of that number. If not, it resets the counter to 1, adds the count and the number to the compressed byte, and move on. Yeah. So decompressor version 1. Let's say we have. Okay, so we have this byte. You guys probably already saw it too. Maybe that was wrong. But can you guys guess the decompressed byte using REL, run length encoding? Pause the video here and figure out. Okay, the correct answer will be actually the same, because since this is run length encoding, this is not an advanced algorithm like the Hoffman tree or something like that. So so these algorithms go bit by bit, not by byte or both. So basically, I kind of do like the reverse. Like in those math problems, they teach you have to do the reverse to figure out the original number. So I loop from 0 to length of compressed byte. So 8 times, maybe like 8 times. I check if if the current bit or character is 1 or 0, I don't need to do anything special. I just add it, because it means like there was only one of it in a row. If there's an else, that means there's like a 2 or in front, which means like the number behind it there was multiple of. So I have to, for that amount of the number that was in a row, I have to make a loop from 1 to there, because from 0 to there would be +1. So I make a loop from 1 to the amount of that number appeared, and for each time I add decompressed by that number. Okay, that was TXT compressor version 1 and TXT decompressor version 2.